getting back to my good old presentation over here. One thing I also want to show you now is how you actually work out the acceleration. So to work out the acceleration, I'm going to say I want to work out acceleration from here to here, which is basically going from 5 seconds going all the way up to 10 seconds. I do urge you to sketch this into your book, and you can copy down what I'm doing now, and obviously you can pause the video. So what you do is very similar to before, is you draw in your triangle. Okay, the acceleration equation that we did last lesson is going to be delta V over t, which is change in velocity. So I can see here, I'm guessing that's about 16. Going down here, I can say that's about 6. And the time is going from 10 to minus 5. In my book then, 16 minus 6 is going to be 10. Then you've got 10 minus 5 is going to be 5. Therefore, that pops out as 2 meters per second squared. And, that's basically, how you work out those 2 points there going across nicely. Now, the other one you can do, and I'll change a different color pen, is going through from this point here down to that point there. Exactly the same thing you do again. Acceleration is going to be delta V over delta t. Now, I'm going to have to rub this out so I can fit this in. Again, what you do now is you go down, draw down your dots going down here all the way down to 35. So therefore, the change of velocity now is going from 30. It's going all the way down to 0, and then the time it's going to take is going to be from 35 to 15. Sorry, 35 to 50. Can't add up here. So that's going to be 15, and then what you can do is you can write down 30 over 15, and that's going to be minus 2 meters per second squared. Notice I put the negative in because I'm showing it slowing down. So showing in fact the value as it changes. And that's how you work out the acceleration. Okay, nice and easy. Now, the next bit, which you'll find in your book as well, that you have to do, is also you can find the distance traveled. Now, the distance traveled is dead easy, and it really makes sense. Now, what all it is going to be the distance, so the area underneath the graph. So say, example, I want the distance traveled, and I'm going here from 20 seconds. I'm going here to 35 seconds, and I want to know the distance traveled. What you do is simply the area under the graph. Okay, which is going to be this area here. Now, you see straight away, that's going to be a rectangle. And to work out that area is you've got the width multiplied by the height. So the width is going to be 20 to 35, which my book is going to be 15, and then you're going to multiply it by 30 going here, and you bung that all in your calculator. You're then going to have 450 meters. So basically that gives you distance traveled from here to here. Now going to a different color pen. If I say, example, I will now want it from 35 seconds going all the way to 50 seconds. Okay. Now what you do, again, find the area underneath that spot here. Now all you can see, this is going to be a triangle. So with your triangle, what you do is going to be a half multiplied by the height, which is going to be 30, multiplied by the width, and that's going to be 15, okay, which is going to be a half multiplied by 450, which is equal to 225 meters. So that area, distance traveled from there to there, it's going to be 225 meters. These are more tricky. And this one, again, will be your triangle, a little bit going through here. And some of the times what you have to do, if you've got a really nasty one, which is going to be from here to here, what I would do is work out the area of that triangle, first of all. And then what I do is work out the area of that square underneath. And you add those two together. But you normally will find it's just going to be rectangles and triangles nice like this to work out the distance traveled. Okay, now the worst case scenario. They brought this into the GCSE a few years back. In reality, you very rarely see a distance time graph where you're going to have a nice straight lines. In reality, what happens is your speed or velocity time. Had I distance time graph before? I meant a velocity time graph. Normally, your velocity time graph, what you find is it's going to be a curve like this. Now, to find the area underneath this, you're stuffed. You've got no triangles. You can't use trapezium rule. It's a weird shape. And what you unfortunately have to do is a fantastic counting squares method. What I mean by that is this is going to be what they regard as 1 square. Okay. Now the area of each of these squares is simply going to be your height here, which is going to be 2. And then you multiply it by your width, which is going to be 4. In other words, 2 multiplied by 4 is going to be 8 meters. And you'll find all of this on page 153 in your book. What you have to do then is you start counting your squares. In other words, you first of all got whole squares. I got 1, 2 going through here. And you can see you got 20 going from all whole squares. Then what you've got to do is you've got to estimate saying, well, that plus that, I reckon it makes another square, which is going to be 21. That plus that, for another square, is going to be 22. This one plus that bit, well, no, probably not. That one plus that bit there, probably going to be 23. That one plus that one is going to be a 24. That plus that is probably going to be a 25. And it's about 26 squares. So what you do then is you estimate roughly, you've got going to have your 28 squares, which I've got, so 26, so 26 squares even. I did 26 multiplied by 8, and I got the grand total is about 208 meters. And you'll find examination questions, they will give you a flex. Some people say it's 25, some people say it's 26. You can probably count it yourself and probably come up with a different number. Okay, now what I'm going to do is I'm going to bolt onto this video or the post is, first of all, is I'd like you to do these. These are velocity time graphs calculations. If I can, I'll try and put the answers on Edmodo for you as well. And these basically are likely compulsory to go through. And what you do is you first of all match these up, then you work out the accelerations, we'll match those again to the graphs, and then we have to do is work out the distance traveled. And I've also got a question 4. Now, if that goes really well and you would like a bit extension, is I've got this one over here as well, is I've got this one you can do if you feel you're going to well and you would like an extra question. Now, I'm well aware that some of you are going to find difficult printing this off. If you're really struggling at printing that one off, I've now lost it, back over here, just basically sketch the best you can these graphs and work out the answers. Just sketch them into your book. If you can't, don't worry if you can't print it off. And then going down to number 4, again, if you haven't got graph paper, just sketch your book the best you can. Don't worry about it. I'd like you to have a go at them. Okay. Now, so what I've been through is now I should be able to interpret a velocity time graph, identify acceleration, deceleration, should be able to calculate acceleration from the gradient of velocity time graph, and also calculate the distance traveled.